So we're rolling.
We're rolling.
We are rolling like a ball around a loop, going fast enough.
Okay, so bucket going around in a circle, and we're just going to think about at each of these points kind of around the circle what's happening. The thing that we know that's going to be the same at all of those points is
The radius.
radius, and the force that we know that's going to be the same at all of those points is weight force, right? So we can start by drawing on to all of these the FW. And we know that for it to move in a circular path, the net force has to be what way?
Inwards.
Inwards, has to be a centripetal force. And so what we have to end up with in each of these is a net force. And so the thing, as it's going around in the circle, and I've a little bit cheated in that I've tried to draw the centripetal force equal in size at each point, so it's kind of a bucket going around at constant velocity, which we know doesn't happen. It's going to get slower and slower as it does work against gravity, but just for the purposes of this, let's go with it like this. What does our arm need to do in each of these situations? Provide probably more of a tension force in your arm. What does that tension force have to do?
Make sure the bucket doesn't fly away.
Make sure the bucket doesn't fly away. It's got to add on to the weight force to give the centripetal force, eh? Like we want the centripetal force, we want the double arrowed one, the net force, the resultant, that's what we want our answer to be. So if we look at the bottom, weight's going down, what does our arm have to do in order for this to kind of work? The tension force in our arm has to balance the weight force and provide the centripetal force. So at the bottom of the loop, the bucket feels heavier because you're not just lifting its weight, you're also providing the centripetal force. What about at the top? How big does that tension force need to be at the top?
Pretty much nothing.
No, pretty much nothing. It's just nose to tail there. So at the top, the bucket feels lighter because all that your arm is doing is providing that little top up to make the centripetal force, knowing that the weight force is already there. And our minimum speed case, like our kind of the limit where failure starts to happen, is when the weight force gets bigger than the centripetal force, and so the minimum safe speed happens when that weight force is equal to the centripetal force. We don't need a tension force at all. Over on these side ones here, we can see that we're going to have to do some work. We have to have a force directed like that in order to hold the weight and to provide the centripetal force. In reality, the bucket is going slower and slower and slower as it comes up. So in reality, you're not going to have that kind of vertical component in the tension force doing work against the weight force. The bucket's just going to go slower and slower. But for this to be true, if it were going to move at constant speed, it would need to be like that. Does that with me so far? Okay.
We're getting faster and faster, right?
In reality, if it's like a roller coaster without a motor, or a ball rolling around a loop, or something sliding around a loop, it's going to get slower and slower as it goes up the loop, and then faster and faster as it comes down, just because of gravity. For this, we've kind of said, okay, what if it's moving at constant speed? Just
Gravity's negligible.
say again.
Well, we shouldn't gravity's negligible, surely.
Oh, no, that gravity's providing the weight force.
Oh, I forgot.
Yeah. Okay, so our minimum possible speed that we can go around the loop at is when the weight force is equal to the centripetal force, and that's the kind of approach we're using if we're trying to test if a roller coaster loop is safe, is working out, is this thing going to be going the minimum speed up the top of the loop or not. Like if you want to know if the roller coaster is safe before you get on it, look at how high the hill is, work out how fast you're going to be going. Are you going to be going fast enough at the top of the loop? FW is mg, FC is mv squared over r. And so the cool thing that we notice is that if we're trying to rearrange that for v, we cancel out the m's to start with and get g equals v squared over r, and so v is just equal to the square root of g r. So that's kind of cool. As long as the speed's higher than that, we're going to be okay.